Hi Tepang, thanks so much for your question. So in this one, we're going to be looking at how we can use our exponents to solve for this, even though we've got 4 on the other side, and we're going to be solving for x in this case. But first, we're going to simplify what we have on the left in order for it to give us something that we can work with and compare that to what's on the right. So the first thing we can do here is split this. We can split 5 to the power 3x minus 1. Because there's a rule that says if I have x to the power m multiplied by x to the power n, x doesn't really matter. It doesn't really matter what number it is. It could be 5 in this case, as we see here. Now, if I have that, I can write that as x to the power m plus n, which is what they've actually done over here. Now, what we're going to do is we're going to do the opposite of what they've done here. So we're going to write 5 to the power 3x multiplied by 5 to the power negative 1. So we're going to have 5 to the power 3x minus 5 to the power 3x multiplied by 5 to the power negative 1 is equal to 4. And in this case, we can see that we have 5 to the power 3x common in both these terms. So that's what we're going to take out in this case. So we're going to have 5 to the power 3x. Take that out as a common factor. We're going to have 1 minus 5 to the power negative 1 left over, which is going to give us 4. Let's simplify what's in the brackets over here. We're going to have 5 to the power 3x. That's going to give us 1 minus 1 over 5, and that's equal to 4. Then we're going to get 5 to the power 3x is equal to, now 1 is the same thing as 5 over 5, and 5 over 5 minus 1 over 5, that's going to give us 4 over 5, and that's equal to 4. But now I want to isolate 5 to the power 3x because that's what we're solving for. We're solving for x, so I want this one to be on its own. And the way we're going to be able to do that is if I multiply this side by 5 over 4, also multiply this side by 5 over 4, because what I do on the left-hand side, I also have to do on the right-hand side to balance the equation. And what that's going to do here is that 5 and that 5 are going to cancel each other, and that 4 and that 4 are going to cancel each other, and all we're going to have on this side is 5 to the power 3x. On this side, 4 and 4 are going to cancel each other, and I'm going to have 5 left over. So let's clean that up. I'm going to write it over here. If we clean that up, what we're going to have left is 5 to the power 3x is equal to 5. That 5 that we've got left on that side. But now I'm going to write that as 5 to the power 1 because that's exactly the same thing. So we're going to have 5 to the power 1. Now, because my bases are the same, I can equate my exponents to each other. Therefore, 3x is going to equal to 1. And now I can solve for x. I can divide both sides by 3, divide over here by 3, and divide over here by 3. And x will then be equal to 1 over 3. And that's the answer we're looking for with 1.2.1. Okay, I hope this was helpful. If you need help with any more of these, you can look at the app, try a couple more of them just to get used to the idea. All right, all the best.